Problem number 4. The head of a rivet has a hemispherical shape of radius 30 mm, that is spherical radius 30 mm. The diameter and height of the shank portion is 40 mm and 50 mm respectively. Draw the isometric projection. The moment we see the isometric projection, we are supposed to draw the isometric scale. At the same time, in a combination of solid, here is a rivet with the head portion hemispherical and the shank portion cylindrical. Any one component is spherical, then obviously the problems become isometric. So even if they ask to draw the isometric view, then we are supposed to draw the isometric projection. So the first step is we take the suitable scales. Here the hemispherical radius is given as 30 mm, so therefore the spherical diameter is 60 mm and the maximum dimension is 60 mm. So first step is we are supposed to draw the isometric scale for accommodating 60 mm. So we have a isometric scale. First we just draw isometric scale. So we just take a horizontal line with 30 degree and 45 degree. With the help of this 30 and 45 degree, we can construct an isometric scale. We need a maximum dimension of 60 mm. So we can construct the isometric scale in such a way that we can accommodate maximum 60 mm. Again, if this is 45 degree line, then we draw one more line, that is 30 degree line. We can join the 30 degree line. Yes, upon this we can construct a 70 mm scale. 1, 2, 3, 4, 5, 6, 7. Again we have 1, 2, 3, 4, 5, 6. Now just draw one vertical. 10, 20, 30, 40, 50, 60 and so on. Then the corresponding isometric scale, the 30 degree line. So we'll be able to get isometric 20, then isometric 30, again isometric 40, isometric 40. What we get on 30 degree is iso. What we put on 45 degree is actual. Therefore actual 10 mm becomes iso 10 mm. Actual 15 mm becomes iso 15 mm. Actual 30 mm becomes iso 30 mm. Actual 40 mm becomes iso 40 mm here. Similarly, actual 50 mm becomes iso 50 here. Next, the last one, actual 60 becomes iso 60. Now with the help of this, we can draw the front view of the combination of solid. This is iso scale. We just draw the front view of the combination of solid, starting with the the rivet with a shank of diameter 40 mm, shank diameter is 40 mm, height is 50 mm. So therefore we take the shank radius 20 mm. So naturally we are supposed to take the diameter of the shank portion is given as 40 mm. So therefore we take the ISO 40. So the radius becomes ISO 20. We take 20 mm ISO radius. And we take ISO 50. ISO 50 is given like this. So we take the height. So now we can draw the rectangle. We can project this. So this is the front view of a cylindrical shank. Therefore we have the head portion as a kind of semicircle. Again the radius of the hemisphere is given as 30 mm. We take ISO 30. We take ISO 30. ISO 30 can be taken, and we just make the semicircle over here. So this is the front view of the combination of solid. Let's say we take this, hemisphere. So it's again called spherical radius SR 30, but it is given in isometric scale. Again the height of the shank portion is 50 mm. We take this 50. We make it 50 here. So this height is ISO 50. Now that we can convert this combination of solid into a perspective projection. So we take, as usual, we take a reference line, base reference line, and a starting point, 30-degree line on both sides. So this 30-degree line is taken. Axis, here is one line and one more line on the right hand side. So now this diameter is 40 mm. We take 40 mm, that is ISO 40. Take this. Same thing available here also. We take this 40 mm, we construct a square for this elliptical shape, one line through this. ISO 20 is taken, that is, this distance is taken, ISO 20 on either side. Yes, here. So now with the help of 4 center method, we can convert the circular portion of the cylinder into an elliptical portion now. So this can be drawn like this, and we can connect this center with this corner. Similarly, this center can be connected with an opposite corner. Thereby we get this arc, we make it like this, and the other side we make the arc like this. Similarly, we can make this arc connecting these 2 points, 2 and 1 can be joined. That's it, right is drawn. Just about the isometric height, the height of the shank is 50 mm. So we take this isometric 50. Yes, isometric 50 is taken. Isometric 50 is taken. Line here. On either side we take spherical radius 30. So it is ISO 30. We take this 30, make arc on both the sides. We can draw lines through this 2 points. Lines through these 2 points. Yes, then we can draw one more line through the center. Again we can take 30 mm distance on either side. Take 30 mm distance on either side. With the other reference edge, with this reference edge, we can make use of this side. Yes, this side can be drawn. Similarly, here also we can draw. So now with the help of this 4 center method, we can convert circle into ellipse here. So what we do, this center has to be joined with this corner. Center should be joined with this corner. Similarly, this center should be joined with the opposite corner. These 2 corners and this center we join these two corners and this center. Make use of this. We can draw one arc here. Similarly, with the help of this, we can draw another arc here. Again, this with this center and this radius, we can make arc. Now, keeping this as center, this as radius, we can make the hemisphere. This is the true radius of 30 mm. Now we can take this height and we can make it straight. That is the height of the shank. Similarly, here at this end also we can make the height of the shank. Here the invisible portions, the hidden portions are not shown. So now we can find the shank diameter is given as this is shank 40. This by 40. The shank height mentioned as 50 mm. That is given here as 50 mm. Yes, this dimension is 50 mm. All are ISO dimensions. So this is ISO 50, and this radius is the true radius, true spherical radius, SR30. So true spherical radius 30 to represent the hemisphere. So we have a hemisphere here. So the ISO 30 radius is taken with the help of a 4 center method. We form the front portion ellipse alone. Then instead of rear portion, we have taken the entire true radius. This extreme line is nothing but the true radius. So true radius is given, it gives us the spherical. And the shank, for the shank portion, we started with the ISO 40. So it is mentioned here. We have to just project and show the dimension of the 40 here at this bottom. Somewhere we just project this. Similarly we project this, then we find out this, we make this is nothing but ISO 40, that is nothing but the diameter of the shank.